Hi and welcome back. We're going to go through question 2 from the mock. Tessa has a small clothes shop in a seaside town. She records the weekly sales figures and she believes that there is a correlation between the temperature and the sales figures. We're given in the question that the PMCC is minus 0.915. We need to conduct a hypothesis test at a 5% level of significance to see whether or not there is. Firstly, we should state our hypothesis. So, using the correct pen, H0 is that rho is equal to 0. You score 0 for this unless you use the correct variable here. Rho is the correct variable, not R. And our alternative hypothesis is that rho is negative, so rho is less than 0. We can claim a mark for that. We're conducting a 5% significance test and it will be one-tailed. So we need to access the tables and look up the critical value for the PMCC with a sample size of 8. We know that the sample size is 8. It tells us in the question here that there are 8 weeks. So we go down the sample size n until we find 8. Going across, that gives us all of those. We want the one where it's 5%, which is 0.6215. So the critical value equals 0.6215. What that means, remember, is that if we have a picture, this is the lineable possible values for the PMCC, ranging from -1 to 1, with the middle value of 0. We're stating that any value that's close enough to 0, any value that's close to 0 is in the acceptance zone. In order for us to think of it as a significant result, it needs to be into this critical region, or this critical region here. Okay, this part up here is the acceptance zone and the acceptance region, and then we have the critical region down there. And what matters is we need to know the value here, the critical value, and we've just identified that as minus 0.6215. Okay, our value, the one that we were given in the question, is 0.91 minus 0.915. That is clearly in the critical region. We just need to state that now. So we're going to state that minus 0.915 modulus of is greater than 0.6215. You can use the modulus on both sides if you want to. And that means that we can reject H0. Therefore, we can reject H0 and we should accept H1. Remember that H0 is that rho, the correlation coefficient, is 0. We're saying it's not 0. And because we've conducted a one-tailed test against the idea that it's negative, we now have evidence that there is a negative correlation. And that question, that answer needs to be given in context, otherwise you don't get the points. So here, I've noted that it's a negative correlation between temperature and sales, not T and S. Okay, good. The next part, if we refer back to the question, asks us to state a possible reason for this correlation. Well, one possible reason is that if the weather's nice, people spend less time shopping. So we should state that. Okay, so moving on, we get to the next part, which gives us some further questions to do. Tessa suggests a linear regression model could be used for these data. State giving a reason. Well, our reason is that minus 0.9 is close to -1, suggesting a linear regression, suggests that the dots are close to a straight line. So that's what we state. And for part D, suggest giving a reason which variable would be the explanatory variable. So if I just picture the graph of this data, we're seeing some kind of negative relationship. We would expect to see T for temperature along the bottom and S for sales. So state giving a reason, which would be the explanatory variable. And for D, temperature because sales depend on temperature rather than the other way around. I mean, it wouldn't make sense to try and change the temperature by buying more clothes or selling more clothes. That just doesn't make sense. Finally, we have part E, give an interpretation of the gradient in this regression equation. It is not enough to say something like, as one goes up, the other goes down, or anything like that. We need exact values, exact explanation here, saying if the temperature goes down by 1 degree, what will happen to the sales, or if the temperature increases by 1 degree, what happens, etc. So we're going to state that if sales increase by 1 degree, sales fall by £171. That's that. Lovely. Thank you.